So up to this point, I don't think you felt this was difficult. Maybe it was a little challenging because you're not as strong in factoring, but I think you agree that 11.1.2 and 11.1.1 are just extensions of each other because that's multiplying. So we've learned how to multiply and divide. Check. Now we're going to learn how to add and subtract. There's different rules, so I suggest you copy this down and write it step by step. So let me give you examples. If I had 3/5 times 1/3. You would go, oh, okay, 3 on top, bottom, bye-bye, 1/5. And that's how we multiplied, right? Factor the top, factor the bottom, factor the top, factor the bottom, cross things off. When you're adding or subtracting, you have to find a common denominator. And some of you go, okay, well, can I add 2? Because if I just add 2 over here, then 3 plus 2 is 5. No, you need to multiply. We've learned that because adding is not the same effect as multiplying. So that means I would need to multiply this by 5, this by 5, this by 3, and this by 3. Really remember, you need to multiply. Okay? And then we would go 9/15 plus 5/15. Add or subtract the top, keep the bottom. Add or subtract the top, keep the bottom. Simplify if you can. You couldn't simplify, so you're done. We're going to be doing that halfway down the page. Okay? So let's start with the number 1. Number 1 says, okay, here we go, and it says make the bottoms the same. So let's zoom in. Oh, look, the bottoms are already the same. So if the bottoms are already the same, then I add or subtract the top. So I'm going to take this and I'm going to add it because it's a plus. 5x plus x is 6x. Y plus negative 5y is negative 4y. And then I keep the bottom, which is 20. And I don't like that the y is first, so I'm going to rewrite it. Add or subtract the top, keep the bottom. That's the mistake some of you make. Now, what's the last step I need to do? Simplify. Oh, well, now this looks like the first day, where you see if you can factor the top and factor the bottom. So I can factor the top. I can take out a 2. And the bottom isn't being added or subtracted, so I can't factor. Now I cross things off. This is being multiplied. This is being multiplied. So 2 goes into 20 10 times. Okay? Now some of you go, what about this 2 and this 10? No, this 2 is being subtracted and that one's being multiplied. They are not doing the same thing. So then I'm left with 3x minus 2y over 10x squared y. State your restrictions. X cannot equal 0. Y cannot equal 0. Some of you are noticing x and y always are 0 when there's nothing being added or subtracted. Okay. Now let's look at number 3. Now what's the difference in number 3 is it's subtraction. What do I always say when it's subtraction? Change the signs of everything to the right. That's the mistake you're going to make, and you know I'm putting that question on the quiz. Okay? So then I go, okay, make the bottoms the same. Oh, cool, they are the same. So I'm good. And then I go a minus a. Well, there's no more a's. 6b minus 2b is 4b. Then the last step I always have to do is check to see if I can simplify. So let's see. No factoring, but I can cross things off. 4 and 4 gone. 1 more b on the bottom, and the a stays. Nothing left on top, comma. A cannot equal 0. B cannot equal 0 because there's nothing being added or subtracted. Okay. Let's look at number 5. What do I do when it's subtraction? Change the signs of everything to the right. And some of you go, well, why don't you change the bottom also? Okay. If I had 1/3 minus 2/3, and I said change the signs. If I change this and change this, then a negative and a negative make a positive, and the subtraction never existed. But if I have 1/3 minus 2/3, and I change the sign of everything to the right, it's still the same. Okay, hopefully that made sense. All right, so now I have 4r minus r is 3r, and negative 3 minus 9 is negative 12, and then I keep the bottom. But you got to know, 60, that it's going to be more difficult than that. So what do? Factor the top. Factor the bottom. It's not magic X, it's GCF. Now it's magic X. Now I cross things off and cross things off. And I look to see, is there anything the same? Yes. 3 on top, 3 on bottom. That's our -4, that's our +4. Those are not the same thing. I cannot cross it off. And some of you go, okay, should I box the bottom now? Don't box the bottom, because then you're going to have to state the restriction, which means you're going to have to factor, and you'd end up with this. So comma, R does not equal 5, R does not equal -4. I don't care about the top. The top is fine. It's the bottom that I have an issue with. Okay. Now that we understand how to do it when the bottoms are the same, the difficult part is how do we make the bottoms the same? So let's go back to the previous problem. What did we do? When we had 3/5 and 1/3, whatever this was, we gave it to that. Whatever this was, we gave it to that. And look at this. You've got a 3 and a 5. You've got a 3 and a 5. You both have the same thing. Now the bottoms are the same. So that's the same game I'm going to play over here with the 7. So they're not the same thing. But if this had a 3x and this had a 2, you've got a 2, you've got a 2. You've got a 3x, you've got a 3x. But if I do something to the bottom, I got to do it to the top. Now I multiply 15x. And I multiply plus. And you know what I like to do? I like to rewrite it like that. So it's just one big addition. 15x plus 4x all over 3x times 2 is 6x. I could rewrite it like this. 15x, let me move this over, and oops, 15x over 6x plus 4x over 6x, and then go 15x plus 4x over 6x, and then go to the next step, but I'd rather go straight to this step right here. Okay? Whatever you want though. And then now I add the top. Sorry. See if I can cross things off. I always have to see if I can simplify. X on top, X on bottom, goodbye. And 19 over 6, no restrictions. It's just a number. We're going to be fine. We're done. Okay? All right. Let's look at number 9. The difference in number 9 is anytime you see subtraction, change the signs of everything to the right. Okay. Now the bottoms are not the same, but I want them to be the same. So this has got a 2. That's got a 2. Okay. That has a y squared, so this needs a y squared that's being multiplied. Now look, y squared, 2, 2, you're even. So that means this is also going to get a y squared. So then I know my bottom is 2y squared. I didn't do anything to the first one, so I just leave it. Now here's the issue, and I want you to see this in on. You got to make sure you're distributing the y squared to the negative x, so that'd be negative xy squared, and then distribute the y squared to the positive 2y, which is positive 2y cubed. And now I look, can I put this with this with this? Nope. Is it in the correct order? And it's fine for me. And I can't cross off the y's because while this has a y and this has a y, that does not. So now I state the restriction, y cannot be 0. It seems not that bad, but it's just gradually getting more and more difficult. So I want you to make sure that you really get the pattern. Okay, I need to make the bottoms the same. So some people go, oh, well, what do I do? Can I just multiply by 3v plus 2? The problem is, then that would be 3v plus 6. So that wouldn't work. So really what this means is that these are two completely different things. Like this is a 3 and this is a 5. Because this is just being multiplied and this is being added. So they're doing two completely different things. You can't find them being similar. So that means if you multiply this by 3 and you multiply this by v plus 6, then 3 times v plus 6, 3 times v plus 6. I will leave it like that on the bottom because I always have to state the restriction. But when I do something to the bottom, I got to do it to the top. If I do something to the bottom, I got to do it to the top. Draw my big old line. Distribute. This is the mistake you guys make. Do the little distributing symbols because then you forget to go 6 times 6, which is 36. And then 3 times 3 is 9. Now I look to see, can I simplify? I sure can. 6v plus 45 over 3v plus 6. Do not multiply the bottom. Keep it factored. Because after you're done, you have to see if you can simplify. I can take out a 3. 2v plus 15. Now, 3 on top, 3 on bottom. Bye-bye. I'm left with 2v plus 15 over v plus 6. What's the restriction? V cannot equal negative 6. Okay. All right. Let's try the next one. I want us to get through all of these so that you can really make sure you're solid on your end. Okay. Let me check the time. We're good. Okay. So this is a 2 and this is a 6, n plus 6. It seems similar to this one. However, I can actually factor the bottom. Now, what that means is I don't go, hey, this has a 6, this needs a 6. If I multiplied this by 3, what is 3 times 2? 6. Oh, it's being multiplied. So really, I'm multiplying by 3, n plus 1. 3 times 2, 6, n plus 1. So that means I'm really multiplying this by 3, n plus 1, which is really 3n plus 3. So now I rewrite the bottom, 6n plus 1. This isn't easy. I understand it'll take practice. Attend my Zooms, blah, blah, blah. Distribute. Distribute. 15n squared plus 15n, and then plus 6n. It ends on its way out. Sorry about that. So then I am left with 15 plus 6 is 21n. And now I see if I can simplify. I can take out a 3, n, and then I'm left with 5, n plus 7. And now I cross things off, 3 and 6, because they're both being multiplied, 2. I don't think I can do anything else. So I'm left with n, 5n plus 7. This is a good time for me to highlight. And then a 2 and an n plus 1. I don't have a problem with my 2 on the bottom, just my n plus 1. N cannot equal negative 1. A mistake. I think I'm going to do it in the next video. No, we're good on time. Okay, the next one. Some of you go, I know, you just multiply this by negative 2. And then it's the same. No, because negative 2 times p is negative 2p. So they are not the same thing at all, which means this gets a p minus 6. P minus 6. This gets a p plus 3. What you do to the bottom, you got to do the top. I don't want you to multiply the bottom. Keep it factored so you can state the restrictions. And then distribute. 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 Okay, you can always slow down my video. Then I simplify. Let's see, we got a 3p squared. 9p plus 2p is 11p minus 12 over p minus 6, p plus 3. And for time, I know that you cannot factor that, so you're done. So p is greater than 6, p is not equal to negative 3, just because I'm running out of time. You would check to see if you could magic exit, and you can't, so you're done. Okay? We're going to skip number 17 for time, and I want us to do this last one. Okay? So, what's the first thing I do whenever it's minus? Change the signs of everything to the right. So some of you go, well, this has a 3 and so does that, so I just go plus 3. You're not adding. You have to be able to multiply. So this is 3 n plus 1. Okay, so I should have had white out for that. So if you look in the bottom first one, the 3 is being multiplied. In the bottom second one, the 3 is being multiplied. So they both have a 3. That means you have to give this one an n, and you have to give this one an n plus 1. Now look, 3n, n plus 1. 3n, n plus 1. So now I have my denominator. Distribute. Distribute, distribute. I cannot magic X this. I know that because I can't find two numbers that multiply to get 20 and add to 5. So n cannot equal 0. N cannot equal negative 1. Okay? And I think I'm about to run out of time. So I'll do the homework next.